Hey everybody, welcome to the stream. I'm gonna talk about a few things today. Starting off with trying to explain what I've learned so far about assembly language. Sorry about this view. This I'm still a very new streamer. This is funky. Okay, there we go. Yeah, sorry for this too. I was just walking the dog wearing a baseball cap. Um, mm, Let me zoom in a tiny bit. Okay, so I've been going through this book about what's called high level assembly language, um, which is something invented by the author of the book, who's like a very knowledgeable programmer and educator about assembly language. I guess I should show you a bit of that. He's not only an expert in assembly, but just C as well and computer architecture. This is the one I've been going through. I sort of leapfrogged or sort of jumped over from this other book by him. His name's Randall Hyde. I was reading Understanding the Machine. I've read a lot of that actually, which talks about how computers actually work under the hood and what happens. What happens when you run a program? Like what really happens? And there's plenty of high level assembly in it, and I just found myself wanting to learn that properly. And yeah, I could read something about actual assembly language, whereas this is like pretend assembly that actually compiles to real assembly. But I actually think it's probably a nice baby step, and there's plenty of complexity without without jumping into the real stuff right away. So um, I actually just wanted to talk about one little thing, one surprising thing about how assembly works uh, compared to high level languages. And it's this. In Python, you generally you generally wouldn't do something like this. You generally wouldn't do uh, global storage, and then you generally probably wouldn't write a function that mutates that global storage. Generally speaking, like um, add a value to storage, right? And then how do you do this in Python? I don't, can we actually address global storage directly here? I can't remember. We'll find out in a second. Right, so this is like the definition of a side effect. This function doesn't do anything except mutate the global storage variable. Let's just make sure this works. I'm not sure it does. It does. Okay, so that mutated it. Maybe there's scenarios where you would do this. Maybe if you're making a toy application and you don't want to spin up a real database, and you just want like an in-memory database that's just a Python structure, you do something like this, right? But generally, it's surprising. And so what I've run into in assembly that's a bit surprising is you'll do operations. You'll call, what are these called? You'll do an assembly operation like allocate some memory, right? That's a thing you could definitely be doing in assembly, at least high level assembly. I think probably any assembly. And that that, when you allocate the memory, it actually puts the address, the starting address of the memory that you just allocated into a register. which is a thing on the processor that stores values for you. It's like the fastest possible, it's the fastest place to store things. And the registers are not purely for storing information. A lot of them have special purposes. That makes me think of the movie The Jerk. Anyway, special purpose. So let's, when I do assembly, I'm having to do it in this virtual Ubuntu machine. Vagrant. Is it awake? Probably. No. Up. The high level assembly compiler doesn't work on Mac OS, at least not like a modern version of it. So I'm doing it in this Ubuntu box. Let's see if I remember enough assembly syntax and operators to even demonstrate this to you. Obviously, I haven't pre-baked anything. We're about to SSHN. I just want to check chat just in case. Cool. So here we are. I think learn assembly is where I've been doing a lot of this stuff. And the way that you compile HLA to binary is HLA, the name of the thing, hello.hla. Wait a second. It's possible I didn't set up the compiler on this box. I was using a different box before. Let's grab it real quick. HLA compiler, Linux. Dude, change your name. HLA download for 64-bit Linux. So let's get it ready here. I vaguely remember this. There's another character that goes in there, but I don't remember what the character is. We're in Ubuntu 22. libc 6. I don't even dive deep into these things. But I really don't know how anybody survived before Stack Overflow. Okay, did that, and then we'll download this. And there's more than just this required, but it's going to symlink the HLA executable into the path. I may not have to do that if I actually follow the directions here. Oh yeah. Actually, I should do this first. Where am I? Home, vagrant, user HLA, user bin, HLA. I don't think it's going to work yet, but let's try it anyway. Yeah, okay. I got to do some more stuff. There is no this. I don't know what this DB root thing is. It seems like maybe it's a bit outdated. Path equals, oops, that. Good enough. Oh. We'll see if this works. Oh, yeah, okay. We'll put this in there. Did I do that right? HLA lib. Maybe it'll work now? No. HLA lib, yeah, we did set that. Do I have to log out? Echo HLA lib. Yeah, I did. I did. What's going on? Maybe I shouldn't have made that symlink. It worked before. Maybe HLA parse should be symlinked as well. That doesn't seem to... All right, just out of... Oops. I don't think this is the problem, but I'm logging out and back in. Do I have to make it executable? Don't know. It was already executable. What have I done differently this time? Okay, so it's there, and could not locate the HLA lib file, lib.a file. It is hard-coded to look for its things somewhere other than user/bin/HLA. Oh, also, wait, yeah, user HLA isn't a directory. I imagine that's the problem. guess we could just symlink the entire directory. Let's try. Let's remove this one. User bin HLA. Oh, my bad. Let's HLA to HLA. That might be enough. And now let's change this to, or rather, let's source it, see if this makes a difference. Ah, right. Let's just make an alias, I guess. Alias HLA equals user HLA HLA. User HLA. Oh no. Yeah. User HLA ls user bin HLA. Yeah. Bin. Right. Okay. Oof. That's the long road to getting the HLA compiler running on Ubuntu. So it was very quiet about it, but it did compile hello.hla to this executable, and it also looks like it produced this byproduct of the actual assembly. Let's peek at that to see if I'm right. That's not assembly, but it could be. I don't know what that is, to be honest. But if we run hello, it works. And finally, let's actually look at the assembly. So there's some niceties included in HLA. This standard out.put isn't a thing in real assembly. So this isn't a great example to talk about the side effects I wanted to. So let's move on from it, or maybe let's contrive something. We could actually write some real assembly, real-ish, if I can remember enough about flat assembly. Flat assembly is installed here, isn't it? Yeah. So I'm jumping topics into some more like real assembly, but it won't be too daunting. In fact, it'll be kind of a nice challenge for me to see if I remember any of those. Let's just do side effects dot assembly. Format elf executable. Maybe. Format. Ooh, I almost remembered this little line here. How are the sections labeled? There's some boilerplate. This is where you put the program. Segment, readable, executable. And then this is where you put the data. Segment, readable, writable. Entry, let's say something other than main, just to show that it's not a magic word in assembly. Entry, side effects, demo. And then we can say, and that's referring to a label, and there's the label. So anything under this is going to be the program until it sees a section like this. This is where the program goes, or the procedure, as we say. The procedure labeled with side effects demo. This is where we put our data. We're just going to initialize a little variable that's a byte, I think. Let's see. User input DB stands for byte. I don't know what D stands for. User input DB. I'm cheating here. Yeah. It's only a byte long, though. Actually, I don't remember if I've done user input before in flat assembler. So this will hold a byte. Flat assembly allocate memory. It's not a complete example. I might have to run with my tail between my legs back to high-level assembly. This will hold a byte. User input DB. If flat assembly is anything like HLA, I should be able to do... Oh, actually, there's all these different types of data. All these different, not types, but sections of constants and variables and other similar things in HLA that I haven't learned about in flat assembly. All right, let's jettison this. And let's do side effects. Side effects .HLA. Okay. This is high-level assembly. Program, side effects, demo, include the standard library, which is a thing in high-level assembly. Let's say word from user. I actually want it to be a pointer. Which is a type. There we go. Oh yeah, it had some interesting old school syntax to say this is a pointer to something. Word from user, P, word from user. Oh. Pointer to car. Begin side effects demo. And side effects demo. So let's say we want to allow the user to give up to 10 characters. That would be 10 bytes plus the termination byte, so 11. Okay, I think we're close to the side effect I wanted to show. And is this the right syntax? I'm not sure. This is the first time I'm writing anything like this. In a high-level language, one that maybe has something like mem.alloc, I would like C has malloc, which does this very thing. It returns, I think, pointer to the either an address or a pointer to the address of the allocation, whereas this doesn't. It does and it doesn't. It puts the start address of this block of memory into a register. Which register is it? That's esoteric knowledge. It's always the same register, but the name of this method, alloc, doesn't tell you what register it's going to. You just have to know. I think it's EAX. Let's find out. EAX. So this always moves the starting address of the allocated memory block into the EAX register. You just have to know that. And this is, my long-winded stream to talk about this side effect, this thing. It doesn't really happen. You don't generally design high-level programs, use high-level languages to write programs that magically place a value into some other place when you call like a function. I mean, this isn't even exactly analogous to this, because here we're at least, I guess the analogous thing would be something like add value to storage, append the address of the value. You can actually do that. Python get address of variable. Hex of ID? Really? That's it? Address of. Port C type. Huh? Oh, it's ID. It'd be like this. It's a funky example because this is a constant. 5 is a constant. But I think it'll work anyway. ID. Let's just to make it look computery, we'll do hex of ID. And we'll zero out global storage. So add a value to storage. And now global storage has a list of memory addresses. So yeah, that's a pretty direct analogy. You wouldn't ever do this in Python. You wouldn't do this on purpose unless you're doing a demo or playing a trick on someone, right? Not only are you mutating a global array or list in this case when you call the function, but you're not storing the value, you're storing the address of the value. But that's the very thing, that's the expected effect when you allocate memory in high level assembly. There is no second argument here to put it in another register or to just be explicit about what register it's going to for the reader. That'd be weird. But that's just the esoteric knowledge you have to have. And just to prove it out, let's now move. Is move a function in this language? Yeah. Move. The first argument is the source. This isn't true in all assembly language. The first argument is the source. The second argument is the destination. So we're going to move the value in the EAX register into the P word from user, the pointer to the word from user. And then I actually want to print out something. Another nicety built in here. Standard out dot put address held by P word from user. We'll see what this actually prints out. NL is new line. Let's see if this works. HLA side effects. Misuse of this reserved word. Line 8. Oh. It's possible we're not allowed to allocate memory in the program.